Hello everyone, today we're going to talk about coordinate planes and how to find the distance between points that are on one. So to begin, I want to talk about some attributes of the coordinate plane so we can further understand it before we get into some examples. So to start with, we can look at some axes here. The horizontal one we will call the x-axis, and that is this line right here that just runs across it from left to right. And the axis, the y-axis here, is the one that runs from bottom to top. So that's this entire line. This one's the x-axis, and the one that runs from top to bottom is the y-axis. That's an important detail to know. As you go further in math, it will commonly be referred to, especially the y-axis. It's very important. Another detail to mention is that we divide this into 4 quadrants. You'll see there's 4 squares. First one is quadrant 1 up here. And then we go counterclockwise. So this one is quadrant 2. This one is quadrant 3. And this one is quadrant 4. It's typically wrote out in Roman numerals, however, you don't need to describe it that way. And then another important detail is that for the x-axis, we're going to write some directions here. As you go left, you decrease, and as you go to the right, you increase. And for the y-axis, draw this here. As you go up, you increase, and as you go down, you decrease. And we can see that on this pre-drawn one. As you go to the right on the x-axis, your positive numbers get larger. You can imagine you're counting up. And as you go left on the x-axis, they get smaller. You can imagine you're counting down. And then we can see that on the y-axis, as you go lower, it goes lower in value, which intuitively makes sense. And as it goes higher, the value of it increases. So with all that in mind, we can start placing some points, and then we can talk about how to find the distance between points on any given graph. So let's say we placed a point right here. If you don't have any experience with one of these coordinate planes, it might be slightly confusing, but let's look over here. This is the way that we describe points on a coordinate plane. We'll put them in parentheses with a comma separating the values, and we'll say x and y. Now you can look back on here, and we talked about how to count these points as you go through it. So right here we got 1, 2, 3, and that's for the x. And then for the y, we can count out 1, 2. And that's for the y. So this point we could describe as 3, 2. Now let's have another point, maybe somewhere over here is a good spot. We can count over 1, 2, 3. We're going left, so x would be -3. And now let's count up 1, 2, 3, 4, 5, 6, 7. Reaches it. So that'd be 7. So we would describe this point as 3, 7. -3, 7. Yep. Very important detail there, otherwise the math just doesn't work. So we got -3, 7 as the other point. So we got points 3, 2 and -3, 7. Now if we want to find the distance between these points, we're going to have to use our old friend, the Pythagorean theorem. And initially that might be a little confusing as to why we're using it, but we can draw out a triangle, and since we know how the Pythagorean theorem works, a little review, a squared plus b squared equals c squared, we can find this c squared value, which represents the distance between points. So an easy way to do it without having to look at the graph, although if you can draw a graph, it will definitely be helpful for you. You can look at the distance between the x points and the distance between the y points. Those will be a, b, and then use those to find c. So let's look at that. First, let's find the difference between 3 and -3. So we're going to do 3 minus -3, which is the same thing as saying 3 plus 3, which is a distance of 6. So that's our first value, and we can call that one a. Our second value, we can do, let's see, 2 minus 7, which will be -5, and we can say that is b as well. Now, keep in mind, it doesn't matter what value you subtract from the other one, because in the Pythagorean theorem, we do square each value, so it's just speaking in terms of absolute values. Everything's positive, so that doesn't necessarily matter. But your teacher, for example, might want you to keep consistency, so it's just something to keep in mind. But now plugging these values into the Pythagorean theorem, we can say 6 squared plus 5 squared equals c squared. So that's 36 plus 25 equals c squared. And that would be 61 equals c squared. And c equals the square root of 61. So implementing the Pythagorean theorem in this example, we found that this side length right here is equal to the square root of 61. And the difference between the x values would be right here. And the difference between the y values we found are right here. So that's how the math from the Pythagorean theorem actually came about. But you can just remember it as the distance between the x you can call a, the distance between the y you can call b, and just plug into the nice theory. But if you do forget it, it can be helpful to understand where that math comes from in case you want to use it just to kind of guide you better. So let's answer some example problems here just to test understanding. If you want to take a second and try to do this by yourself, feel free to pause the video. I'll give you guys a second and then we'll get right into this. So starting with the first question here, we have what quadrant are these points in? And I did want to give a reminder of how quadrants worked. We start up here with the first one, and then we go counterclockwise, just adding up, and typically they're wrote out in Roman numerals. However, this just means 1, 2, 3, 4, and we just write that out in Roman numerals. So we can see that all these points fall in quadrant 1. What are the coordinates for these points? We'll do that individually for each one. We can see that the x is 1 here, 1 there. So we'll call this point right here 1, 1. We can see we go over 6, 1 more than 5. And then this one is also 6, 1 more than 5. So that point is 6, 6. We can see we got a 2x here, and 10's already labeled. So call that one 2, 10. And a reminder that all these points are in terms of x, y. So first you find the x value corresponded, and then you find the y value corresponded. So we can label them out here. We got 1, 1, 6, 6, and 2, 10. Those will be our 3 points. And we're going to call, let's see here, we're going to call this one A, this one B, and this one C. So let's find the distance from, let's see, A to C. So we'll use our good old Pythagorean theorem for something like this, which you know is a squared plus b squared equals c squared. And let's look here. This is A, and C would be this one. So we can take the math that we used on that first example problem to solve this. We got points 1, 1, 2, 10. We're going to find the difference between the x, which would be 2 minus 1. So we call that A. And the difference between the y's, which we can say is 10 minus 1, which equals b. And that means that A equals 1, b equals 9. And we're going to plug that into the Pythagorean theorem, a squared plus b squared equals c squared, to find the third side of that triangle. So we know that A is 1, 1 squared is 1, and then we know that 9 is b, b squared is 81, and that equals c squared, meaning that c squared equals 82, or we'll put the final answer over here, that c is the square root of 82. And now the final one is a bit of a trick question, but I wanted to put it in because these are the type of problem-solving situations you might find yourself in on a test. So looking at these 3 points here, imagine that is a perfectly straight line, and that one is too, and that one is also a perfectly straight line. What we can do is find the distance from A to B, B to C, and we can find that as the base and the height, and we use that to find the area. So this will be a slightly longer one, but it will show us the power of the Pythagorean theorem, definitely. So going from A to B, I'll try to go through this a little faster. We got B, which is 6, 6, and A, which is 1, 1. Get that out of there. So we got 5 and 5 as the differences here. So this is A, B, square that, and then we're going to find c squared. So this is saying that 50 equals c squared, which is c equals the square root of 50. And this will be what we would call the base right here. For the yeah, I guess as a reminder, the equation for the triangle is base times height all over 2. So now let's find the height now that we have the base, and that would be the distance from B to C. So we got 2, 10 for C, and B would be 6, 6. Let's find the differences here. We got 6 minus 2, that'd be 4. And then 6 minus 10, which is negative 4. We're going to be squaring these values and setting that equal to C squared, because this would be A, that would be B. 16 plus 16 equals C squared. And this says that C squared equals 32, or that C is the square root of 32. So I'm not going to simplify too much further into this, but I did want to write out some sort of final answer regardless. I suppose we can actually get a calculator involved in this. Just get a nice answer for the end. So we have that, let's write some of the details we have. We have base equals the square root of 50, and that the height equals the square root of 32. So we can just simply plug these values into the equation. And let's look here. So we have 50 times the square root of 32 equals 2. And we're going to use some rules here. We're going to say that the top would be the square root of 50 times 32 all over 2. Because if you multiply 2 square roots like that, that is how the math comes out. And now let's plug some of these values into a calculator. So this would be the square root of 1600 all over 2. I believe the top should be 40. Yep. So that means 40 over 2, which means 20. And this would be 20 units squared. So the math did work out super nice there. You might have some problems that aren't nearly as clean. But kind of as a recap of what we did there, because there's a lot on the screen, and that was more of a complicated problem. First, we found the distance between A and C for this problem here, and we could just use the 2 coordinates in the Pythagorean theorem to find that. And then to find the area, what we did was find the difference between A and B. The distance there would be the base. The distance between B and C would be the height. And then we can plug those into the equation for the area of a triangle. And then we could find the area from that, which would just be everything on the inside of this triangle, which is definitely some cool math and a good example of how this can be applied definitely in real life problems as well, and not just on a test. So if you guys have any other questions, feel free to leave them in the comments. I hope this video was very educational. This is definitely one of the more cornerstone parts of geometry and will help you going into algebra. So thank you for watching, and I'll see you guys in the next one.